everyone. This is Nathan Landsman from QBuild. Thank you everyone for joining us for today's webinar hosted by QBuild Software. The title of today's webinar is NestLink, Bridging the Gap Between ERP and Nesting. So we're going to be talking about QBuild's integration between nesting software and ERP systems. So our agenda for today, we're going to be just briefly going over who QBuild is, a little bit about us, a little bit about what we do here at QBuild, what we're all about. Take a look at some of the different products and different integrations that we have as part of our product portfolio. And then we're going to start getting into the nitty-gritty about the nesting process. What are the nesting challenges that organizations are facing these days with these these siloed pieces of software, your ERP system and your nesting software, and through my conversations with different organizations, what I've seen their challenges, the different types of challenges they face. Hopefully they resonate with you and with potentially some of the challenges that you're currently facing today. I'll then hop into a quick demonstration of our NestLink product, talk a little bit about some of the benefits, related back to some of those challenges that we described earlier, and then just have some contact us information on how you can get a hold of us if you want to learn more and have more detailed discussions around your explicit processes and your pain points regarding this process. So just a quick slide to introduce who your presenters are today. So my name is Nathan Landsman. I'm the product manager here at QBuild Software. I'm joined today by Gal Benoit, and he is one of our account managers, account and project managers at QBuild Software. So we're both mechanical engineers by education, hailing from Canada, and between the two of us, we have vast experience working with different CAD, PDM, PLM systems, as well as a vast array of different nesting software systems. So there's our mug shots, just so you know who's talking here. Now, what does QBuild do for customers? What is our company's motto, and what do we strive for as an organization? So we strive to reduce engineering costs by making engineers more productive. And we do that by providing these different engineering software to ERP integrations, and we've been doing this for a little bit over 18 years now. So the goal of all of these different integrations is really so that your engineers can be more productive. They can spend more time doing engineering work instead of data management. A lot of engineers are doing manual data entry. They're spending a lot of time doing not really engineering work. They're spending time doing work that could be better spent doing stuff more focused on their engineering degree. Through these integrations, we also strive to enable swift, clear cross-department communication. If we can communicate better, we can be more effective, and just in general, make life easier for your engineering teams and your manufacturing teams. If all of these different disparate systems can communicate together, then everyone's dealing with the same information. Everyone knows exactly what each system is saying, and we can eliminate a lot of confusion and manual rectifying of different data. What does this look like from a high-level organizational point of view? So we've got different values, different benefits that we see across the organization, right from the user value. How is the user going to benefit from these different types of integrations? Less data entry, we free up manufacturing resources. This is especially key at this point in just the manufacturing space, right? It's getting harder and harder to hire people, getting harder and harder to keep people. So if we can automate in any kind of way, then that means that the personnel that you have on staff now can use that time that they're saving to do more more valuable work. And that means that we have, we get process value, we get department value, right? Because we spend less time doing these things, these manual efforts, these redundant steps in our data flows. And overall, we just get a better overhead ratio at the organizational level. We can sell more products, means we can make more money. And how do we do this? This all comes back to the different integrations that we can provide, right? So we provide these productivity tools that touch a lot of different points in the engineering space, right? So bill of material, engineering changes, sheet library synchronizations, sheet usage reporting, which are kind of the topics that we're going to focus on today. But we build all of these integrations, again, to provide that value and that automation back to your engineering team. Now, these are, a slew, there's a lot of logos on here, but I wanted to put this slide in here just to give you an idea as to who we work with, and just the breadth of the QBuild organization and the breadth of our solution space, right? So we have on the left-hand side a bunch of different ERP partners that we have, from Abbas to E2, Acumatica, Microsoft, JobScope, Plex, ECI. There's a lot of them in there. If you don't see your ERP in this list, don't worry, I just couldn't fit all of them on the page here, but we do have an extensive list of ERP partners that we work with to provide these different types of engineering integrations. Again, if you don't see your ERP on this list here, don't worry. Likely we have integrated to them or potentially are looking to integrate to them. On the CAD and on the nesting software side, we've got some of the big players here in the nesting software world: Sigmatech, ProNest, Trumpf, Kinetic, Columbus from ESAB, and Encel. These are just to name a few. We do have a few more that we work with. So, Bystronic, PEP, some of these other organizations that we have spoken with and have defined a solution for their nesting software as well. And then a bunch of different CAD systems that we work with as well. So this slide is really just meant to show, like I mentioned, the breadth of the solution space that we work with at QBuild. We have a lot of partners on the ERP, on the CAD, on the engineering system side that we work with closely to provide these integrations between engineering and ERP. And so what does the QBuild solution space look like? It looks a little bit something like this. So we've got NestLink at the bottom there. NestLink is our bidirectional integration between nesting software and ERP, but we have other solutions like CADLink, which is our CAD, PDM, PLM integration to ERP systems, like ECN Manager, which is a tool to help you get away from paper tracking and Excel spreadsheet change management solutions while being integrated into your ERP system, and other pieces of software like PLM, CAD to PLM, CAD connectors, Parts Surfer, and ConfigLink. So inside of the whole ecosystem of where each of these fit in our CAD ERP space, this is kind of the roadmap. These are all the bridges that we create for all the different solutions that we have. So you can see, again, that wide breadth of engineering solution space. We're trying to solve issues and problems or pain points that organizations are currently facing at the engineering level. So this is what our solution map looks like at the moment. If there's anything on here that that you're interested in learning more about, obviously feel free to reach out to us after the webinar. We'd be happy to talk to you about these other product solutions as well. But now to redirect our focus more towards what we're all here to see, which is NestLink. So like I mentioned a few times before, NestLink is our turnkey system designed to tightly connect your nesting software to your ERP. And whenever I like to talk about NestLink, which these days seems to be more and more, is I like to talk about the challenges that organizations are facing, and frame it in a kind of way as to, why did we have to build this integration in the first place? What are the pain points that companies like yourselves might be facing in a world where we have our ERP system that's managing, a lot of the production, the engineering, scheduling, and planning, and we have this nesting software that's sitting out there and optimizing all of my cutting operations on my flat stock or my barn stock, etc. And so I'd like to go through some of the different challenges that I've had experience talking with some of the customers that we have. So the first one is creating nesting software parts and work orders inside of my nesting system. So the way that I frame this is through these different people, these personas that we've created to kind of personify these pain points, right? So we've got Ned the Nester. Ned's not a real person, but he's he's real to me. I've spoken to a lot of Ned the Nesters out there, and they, there's a struggle with the amount of work that's coming out of our ERP system. We're scheduling all of these laser burning operations inside of our ERP system, and we have a bunch of parts that we need to cut from or through our nesting software, right? And to begin even to start to lay out all of these parts and create my nests, I first need to create all of these parts inside of my nesting software, right? So a lot of the times, companies will, print out their production order travelers, their job travelers, and they'll hand it to Ned the Nester, and they say, Ned, please create all of these parts inside of the nesting software and start creating your nests. Now, Ned might have a stack of 200 papers that he has to manually sort by hand. He has to, sort by material thickness, by material type, potentially start thinking about how to sort them, by due dates that the ERP is expecting these parts to be made by. And if you can think about, if I have to sort through 100, 200 pieces of paper every day or every couple of days, it's a lot of manual work. It's a lot of effort for Ned to do all that stuff. It's a lot of manual data entry to create all of those parts inside of the nesting software. Whenever we have manual data entry, of course, there's always room for human error. So this is the first challenge that we explored through a nesting integration, is just getting the front end production requirements out of our ERP system into our nesting software to facilitate communication of those requirements, that demand, to our Ned the Nesters out there. The next challenge that we saw in the industry was updating our ERP to reflect our nesting operations. So what happens after these parts are cut by our laser or plasma or water jet, etc. So again, this is personified through Anna the analyst, who's in our ERP system, and she's struggling to get an understanding of how we should track these operations in our ERP jobs or production orders. A lot of the times, getting this information from our nesting operations, so quantities made, material consumed, cutting times, are either all manually done, so someone has to clock into each of those laser operations. They have to manually enter in how many quantities they've made, and sometimes even manually enter the amount of material that they've consumed. To give you guys an example, I spoke with a company that they were writing down the material consumption on a piece of paper, and that was being handed to someone in the office to enter in as the material consumed for the different parts on their nest. I had an organization that, or company I spoke to, where they were, they per nest were only issuing a full plate of their material on a single job, and all of the other jobs that were on that nest got a 0 material usage. So you can imagine that the job costing for things like that can get a little wacky, right? If I cost the full plate of my sheet to one job, then that job's going to cost a lot more, according to our ERP, than some of these other jobs. And the last example that is extremely common that I found in the industry is backflushing estimated quantities, right? So to get these production orders, these jobs set up inside of our ERP, we have to tell the ERP how much we think that part is going to take from my sheet to manufacture. And a lot of times, not always, but a lot of times, this is something like the rectangular area of the part that we want to cut, right? Engineering, whenever they design their parts, they have their bounding boxes. It's a fairly easy thing to get from engineering, an idea of the bounding area of this part, or even the bounding weight, depending on how you inventory your plates. And a lot of companies use that as the estimate. Now, the problem is if you start backflushing those quantities, one, you're not getting your accurate material consumption. Two, your inventories are going to be completely out of sync because you're consuming usually more than what is actually taking to consume or create that part. So then you start having, different on-hand inventory quantities in your ERP versus what you have on the shop floor, and you have to do some reconciliation work to make sure that these quantities match up. So Anna, the analyst, she is the embodiment of all of those challenges. She's trying to ensure that the information that we have inside of my ERP, inside of our production orders or jobs in the ERP, are accurate and updated in a timely manner. Now, the last challenge that I'll talk about is one that is reflective of both Ned and Anna here. So our nesting software libraries. Inside of most nesting softwares, not all, but most, there is usually capabilities to store plate and sheet information and quantities. This is also true of our ERP system. And having an inventory in both systems can lead to a lot of confusion. It can lead to different errors. And so having our ERP system know exactly how many sheets I have in stock, we want to make sure that our nesting software matches those quantities, just so that we can ensure that any leftovers, any offcuts that come from our jobs are tracked accurately in both systems. So having a synchronization of both sheet libraries can be beneficial as well. If they're out of sync, it can be harmful just because of shop floor confusion. Manually maintaining two different sheet libraries. Whenever we have two data silos, separate, not communicating with each other, can always lead to confusion and manual efforts for reconciliation. So having said all of that, I think you might have an idea where this is going, but let's take a look at NestLink in itself and what it's trying to accomplish. So NestLink is a bidirectional bridge between ERP and your nesting software. There's not really a comprehensive interface to it, and you'll see kind of what that looks like in the demonstration, but it has a few goals. Its goal is to, first rectify those three pain points, right? So we want to create new parts and their geometries in your nesting software based on those ERP production and material requirements. We want to create those new work orders in your nesting software based on those ERP production requirements. We want to automatically issue material and labor transactions back to those ERP jobs or production orders when the nesting is completed, and keep that sheet library in sync so that when we receive plate in our ERP, we can create those plates inside of the nesting software. So all of these should tackle the, the 3 challenges that we talked about previously: getting our demand inside of our nesting software, updating our ERP with cutting results, and keeping our sheet libraries in sync. All right, so let's flip to our NestLink demo. I'm going to minimize this screen here. And open up this. All right. So for today's demonstration, I will be using Acumatica as the ERP, as the backbone for the information for my production orders that I'm going to be sending to the nesting software. And for today's demo, I'm going to be using SigmaNest. If you link the two together, we're going to be showing our NestLink integration between Acumatica and SigmaNest. If you don't use Acumatica, don't worry. Like I said, we have a lot of different ERP partners that we work with. I'll try and kind of explain the general concept of what we're looking at in Acumatica for those that don't use Acumatica, so that you can get a baseline of what we're looking at. The reason why I have to show this ERP system, or any ERP system in general, is because that's where the bulk of the information is coming from. If I just showed data inside a SigmaNest, creating a nest and then sending it off and not showing you the results or not showing you where the data came from, I feel like it would be a much less meaningful demonstration. So having showing the ERP side of things does help complete the story. It does help show where the data is coming from, how it's being passed into the nesting software, and then vice versa. We can see the transactions coming back into the nesting software and into the ERP, and seeing those transactions live coming back. Most ERPs have a very similar concept. They have concepts of either a job, a production order, a work order, different names for essentially the same thing. It is a record of what I want to produce, how many I want to produce it, and when I want to produce them, right? So this is kind of our envelope. This is our basis on what NestLink is looking for when it's trying to extract information from the ERP system. So for my demo today, I'm going to be using 2 different production orders in Acumatica and sending them to SigmaNest, nesting them together, and then updating my Acumatica production orders with those details from my nest. So the story starts inside Acumatica here. I've got my production order number 55. Here is that production order. And these are very, very, very simple production orders. I don't have a large bill of material. I don't have anything of the sorts. These are very simple production orders, and they represent manufacturing this finished good. This bracket here, 569578-0. We want to produce 13 of this bracket here on this production order. And we can see this is in a status of released up here at the top right. If I open up the details of this production order, like I said, very simple structure. We just have a laser operation in it from my WC200 work center, as well as my raw material. So this is my mild steel sheet down here. It has a quantity required. This is my estimate that I've entered. It's a bit of a, it's not really meant to mean anything at this point for the demo. This is really just the estimate. It could be anything that my engineers have decided that I need as my estimate for making this bracket component, right? Like I said, it could be the rectangular area, it could be the rectangular weight, it could be the true area. It is whatever I've set up as my estimated material requirement for manufacturing this part. I can also show on the material itself, MS 120, my mild steel sheet. I have information on the sheet that dictates its thickness, its material type, that NestLink is going to be extracting and sending over to SigmaNest. Now, my second production order is production order number 56. And production order number 56 is exactly the same structure as I showed for production order number 55. The main difference is that it is a different part number, a different inventory ID that we are manufacturing off of this production order. So we have a different part number that we specify that we want to make. This is an enclosure plate. We have quantity of produce, of course, that can be different from our other production order. But if we look at the production details for this production order, we have just a simple structure, same as we had on the previous part, WC200, with our MS120. Now, NestLink itself is a background application. So it's when we install it and when we run it in your live environment, it's going to be running periodically, checking your ERP for new production orders like this that pass a certain set of criteria. And the criteria that we're looking for does depend on the ERP, but mainly what we're looking for is a production order that is in a released state, meaning at least for most ERPs, a released state, meaning that it is ready for production. And we are looking for a specific work center or operation code within this production order. So NestLink will look at all of our released production orders. It'll find those laser or burn or water jet operations within those production orders or jobs. It'll extract those details and create those records inside of SigmaNest. So that's the front end piece of NestLink, where we're getting that production demand from our ERP system, and we are creating it inside of our nesting software. So to do that for the demo here, I'm going to be doing this manually. So I'm going to trigger NestLink in a manual way. I'm going to take this production order number. I'm going to open up my little NestLink interface here, and I'm just going to use this individual tester down here to process these production orders. Normally in a live environment, like I mentioned, NestLink is going to be running in the background. You'll just come in here and hit start, and NestLink will periodically check your ERP system for new production orders or jobs that pass that criteria. We use this individual tester down here during the implementation process so that we can validate that the data that we're pulling from your ERP system is correct and the transactions that we create in your nesting software also look correct. So it's a testing tool that we use during implementation, just so that we're not always starting and stopping in a NestLink application. So I can come in here and I can process these two production orders, 56 and 55. And once that's done, I'm going to hop into my SigmaNest application, and I'm going to open up my work orders. So again, for those unfamiliar with SigmaNest, the SigmaNest application is it's created, or the data that we transfer into SigmaNest is sorted into two stages. We have our work orders, which is essentially an envelope for a part, similar to a production order or a job in the ERP software, and it dictates the work that we need to cut on the nesting software. Some nesting softwares do use this concept. I know ProNest also uses the concept of work orders. Some of them use different naming, more like what you'd find in an ERP system, like Trump uses the production order. But they're all just kind of envelopes for the parts that we need to create. So let's see here first. Let's take a look at our production order here, and we'll process this. Just a moment. There we go. I think that's better. All right. So now we should see those work orders appear inside of SigmaNest. And these are the two work orders that I created here. I've got my Acumatica work production order number, 55 and 56. On this work order, we've got different records. We've got our quantity that we ordered coming from the production requirements inside of that Acumatica production order. We've got our due date coming from that operation due date inside of the ERP. And if I open up this work order, this is where we'll find our part. So here's the part name that I entered. If I click on it, we can see the geometry was brought in. And so there's logic built into NestLink to go out and find the geometry of that file and import it into the nesting software if it's a new geometry. So depending on the nesting software, this logic can be different. Depending on the ERP, the logic can also be different. But there is some basic logic inside of NestLink to say, given this part that I'm trying to make in the ERP, go and find that that DXF file or the DWG file and import it into the nesting software so that we can see the part and start nesting on it. Other details that are important here are things like the material and the thickness. So inside of Acumatica on that sheet material that I showed the attributes for the material and the thickness. These are pulled directly from that raw material specification on that ERP production order. So if you defined a different plate to use on your ERP job or production order, we would pull the plate information, thickness, material, etc., to populate for these parts here. And now the last thing I'll show, just to keep me honest, is the date of creation down here at the far right. 2:32 is 2 minutes ago. So just to show that this is being pulled in live, just because I like to show this just to keep me honest, just to make sure I'm not doing any funny business here. So now, what do we do with these two work orders and these two parts? If I open up the other part, I can see here the different geometry that we pulled in, same material, same thickness. So because they have the same material and the same thickness, I can then create a nest of these parts and cut them on the same plate. So using SigmaNest here, I'm going to create a nest using these two parts. I'm going to create the cutting pattern, the NC code, and then I'm going to simulate the completion of this nest. So from here up until we get to and leave the SigmaNest application, it has nothing to do with NestLink. It has nothing to do with our integration. From this point on, we've created the records inside of SigmaNest, inside of the nesting software. And so our expectation is that the operator can use the information inside of their nesting software, these work orders and these parts and these quantities and these due dates that we're passing live from the ERP, to intelligently plan his nests. So if I'm the operator, I just have to come in here and start creating a nest. I can look at my work orders and I can filter by material, I can filter by thickness, and I can come in and say, all right, these two parts here share the same material and thickness. It looks like they're also due today. So I want to make sure I cut these parts on my laser to ensure I can meet that due date. So that's what I'm going to do. I'm going to select these two parts. I'm going to add them to my nest. I'm going to select my plate here, add them to my nest, and then we're going to auto nest. So this is my nest I generated. Again, this is all Sigma Nest functionality, nothing to do with NestLink here. I'm going to generate my NC code here, cutting path, and I'm going to post this program to my machine. Now here at QBuild, we don't have a laser, unfortunately, but I can simulate the completion of this nest. And the completion of a nest differs from nesting software to nesting software. For Sigma Nest, it is through the program update feature here that we mark a nest as complete. So the cutting has been completed. So when I hit update, this is usually the trigger for NestLink to go in and pick up the details of this nest and go and update my ERP with the cutting results. So the cutting results that we're passing back are things like material consumption, quantity produced, and labor. And we use the information that is provided to us from the nesting software to intelligently create those transactions inside of your ERP system. So things like, well, I'll get to that in a little bit. So let's go ahead and update this program. So this is program number 146, repeat number 1. So I'm going to go ahead and update this. And then just like I did with those production orders, I'm just going to use my individual tester down here to process this program number. So program number 146, I'm going to process it. And this is NestLink currently going out, grabbing the details of this program and updating Acumatica with those 3 transactions that I mentioned. Just like with the production orders, this also would happen in the background, right? These are, what I'm doing here in this demonstration is the individual tester that we use during implementation. We can see our Sigma Nest to Acumatica up here option. This is what we would use when we hit start to go and capture those programs and update Acumatica or any ERP periodically. So NestLink has finished doing its thing. If I hop back into Acumatica, I want you to keep your eyes on these quantities in the middle left-hand side of your screen here. So we've got quantity 4 remaining. We need to produce 4 of these. If I refresh this page, we'll have quantity remaining 0, quantity complete 4. So this is NestLink communicating back to the ERP system that I, on this nest, have completed 4 of these parts. The status, if you noticed, was released, has been changed to completed because there's no next operation after my laser, the operation has been completed. If I look at the production transactions, we can see we've got a labor transaction here. We have a cost transaction and we have a material transaction. So if we look at our material transaction, we can see a quantity here, 1,745. This is in square inches actually. But the quantity that NestLink has calculated being passed back into our ERP system. And this is a calculated quantity. So this quantity here is a calculation that NestLink does based off of the parts area, in this case, plus a percentage of the scrap or the skeleton. So what does that mean and how do we calculate that percentage? We usually calculate it as a ratio of the part areas. So meaning larger parts would get a larger percentage of the scrap and smaller parts would get a smaller percentage of the scrap. If we were to add up the areas that we created and passed back transactionally into the ERP, if there's no remnant, it would add up to a full plate. So here we have our material transaction that we created. We can look at our labor transaction, our labor time that we pass back, and our quantities that we pass back. This is the labor time, typically an estimate of the cutting time that we get from the nesting software. There are modules, depending on the nesting software, where you can track actual cutting times, and we can use that time to feed back into the ERP system. But for the most part, the very simple integration method here, we can use the estimated cutting time from the nesting software, and of course the quantities that we have here that were included on the sheet. If I go to my production order number 55, we'll see a very, very similar story. So our quantity to produce was 13. We have now completed 13 of them. So my status has been changed to complete. Again, because I don't have a next operation after my laser operation. If we look at the production transactions for this work order, and we look at the material, the quantity here is going to be different. So the quantity here, again, is a calculation, right, of that area that we're taking from SigmaNest in this case, calculating a percentage of that scrap and allocating it back to this material here and taking it out of inventory. If we open up our labor, again, very similar story. We've got our quantity here and our estimated cutting time for this component. So we can see in real time here, NestLink take details out of our ERP system, create those records inside of the nesting software. Once we nest and complete those, we can feed that detail back into the ERP system, creating that labor, the quantity, and the material consumption transactions. So let's flip back to my PowerPoint here. And just kind of go over some of those benefits again. So by having this type of integration, this bidirectional integration between these two systems, we can effectively eliminate your nesting data silo. Whenever we have a data silo, it's bad, right? It's not communicating to anything else. It is completely isolated from the rest of my ERP world, right? Which my ERP world is extremely important. It's tracking my production, it's tracking my labor, my costs, my inventory. And so if we can communicate these two systems, then we can start benefiting from a more tightly connected space, and everyone can be speaking the same language in terms of production requirements, due dates, etc. I showed through that front end process where we're extracting those production order records, those quantities, those details from the ERP system and creating those records inside of the nesting software. We can eliminate that manual data entry that Ned the nester would typically have to do to create those parts, to create those work orders inside of his nesting software, as well as those manual transactions that they would have to do through or for the material and labor consumption transaction entries back into the ERP. A lot of companies for this part will use something like MES and a scanner and a shop floor type deal to do that, and that's fine. A lot of the times you'll still have to scan in all of the different parts that you've entered, and you still have to create a transaction for each of them, even if you don't have to manually go in and enter the production order number or the job number and then enter in the quantity. You still have to go in and scan them and then create those transactions from the shop floor. Of course, we can see an increased accuracy and tracking of material consumption in the ERP, and this has a lot of different implications, right? So if we can accurately consume material in our ERP based off the different nests and different layouts from our dynamic nesting, then we can get a more accurate cost, we can get a more accurate inventory, and there's less chances for discrepancies in our systems, less chances to not cost these jobs correctly. And so all of this together just leads to less headaches, and I'm a big fan of chicken wings, so more time for chicken wings. Again, just reiterate some of the integrations and partners that we have. So SigmaTech, which is what I demonstrated here today with the SigmaNest software, ProNest, Kinetic, Columbus, ESAB, Trump, and Encell. they all have their own kind of different integration methods, different modules that we can use to bolster the integration and how we communicate back and forth between the ERP system. But they're all solid nesting softwares that you could use and that you may be using right now. So in terms of our contact info, there's my email address and phone number, as well as Giles. If you would like to reach out to us and have a more detailed conversation around your nesting process and the pain points that you're currently facing, we're always happy to talk to you. Always happy to learn more. And if you liked what you saw here today, then of course do feel free to reach out and we can have those discussions and see if there's a good fit. So with that comes to the end of my presentation. So I think we'll end the webinar here then. Thank you so much everyone for coming and for your time. Hopefully you found this valuable, and hopefully I'll be speaking to you very soon. Thanks everybody.